Great to meet everybody here at the Detection Dispatch number 17. I think this is my fourth, right, at this point. So if you haven't had a chance to catch my earlier ones, I'm Michael Hart. I'm principal data scientist here at Anvilogic, based out of the Northeast, the cold Northeast today, out of Hartford, Connecticut. I have a PhD in computer science and have done machine learning at different companies, Semantic, Google, and Splunk. Scott, why don't you introduce yourself?
Yeah, so Scott Rodgers, based out of Charlotte, master's in analytics and previous experience at TI.
Excellent, excellent. So what are we here to discuss today? Hot topic, large language models and security operations. So three big points that we want to touch on today is how can detection engineers and analysts leverage generative AI? We'll also talk about specifically with your security data lake, how you can integrate these LLMs for maximal effect. But also we got to talk about LLM safety, right? We know these things, tools are prone to hallucinations, other maladaptive, actions. So we'll talk about how we're thinking about it and what measures you can take to protect yourself. But let's talk about the elephant in the room. So am I, Michael Hart, data scientist, going to be replaced by an LLM or a chat, right? So, it's very interesting. I mean, we clearly know that these, models are quite capable, right? You've played with them. So, I would answer that like, am I going to get replaced by asking actually Scott. So Scott, do you still drive your own car?
I do.
You do, right? So I remember not too long ago, there was a pretty bold prediction that, self-driving cars were going to come along and replace, humans at the wheels. And that hasn't quite happened, right? And I think the thing is that we need to think about LLM sort of like how cars have themselves have evolved, right? So we haven't got to the point of full automation, right? We don't have AI driving cars. We're not going to have probably AI tomorrow in your sock doing everything, right? But rather, what can these tools provide you, right? They provide great safety, mechanisms, right? From collision detection, lane drift and things like that. So, I'm not gonna lie, probably 2 times the last 6 months, my car has, alerted me something that I wasn't really paying attention to, right? And that I think that for us, and sort of in this conversation, and how you specifically, right, in your day to day, as we use these technologies, right? How can you be more effective? How can you be more efficient? And also just catch things that you might miss. And hopefully that, as we talk about different use cases of using LLMs, right, that becomes apparent. So let's talk about emerging LLM use cases for the SOC. So this is a humdinger that we saw recently. So Scott, why don't we talk about this little command line over?
Yeah. So like Mike was saying, we really think a lot about LLMs as a co-pilot, helping you in various ways, and we'll go through a few use cases where we see potential for LLMs to add a lot of value. This top one here, so imagine you want to explain a complex security event. So you might have a log like we have on screen here, and I'll give anyone that's interested a chance to say what they think that means in the chat or what that would get interpreted into. But if nobody does, I'll tell you the answer in a second. But so imagine you have that log coming in. The analyst has to look at it. They need to understand everything that's going on in this log. I'll give you a hint. There's some obfuscation going on, so they need to be able to detect that, understand it, and it might be a bit of a tedious task to really understand it unless you're intimately familiar with everything going on there. Like we haven't got any takers on the answer, but I'll go ahead and explain it some. So that $home is referencing an environment variable on your terminal. And then the :0 to 1 is selecting specific characters from that variable. So if we imagine the home is a path that starts with a slash, then basically replace all the stuff there, $home, :0, :1 with the slash, and you have cat space slash Etsy shadow, and the other slash going the wrong direction actually gets ignored. So that turns out to be cat Etsy shadow, but just a tricky way to say it that might bypass filter. Yep. I'll turn it back to Mike for the detection content.
Improvement. Yeah. So definitely, I'm going to admit, right, when it comes to, I don't write a lot of detection content. However, I like to dabble in it, right, to impress my friends here at Anvilogic. And the question is like, how can I improve my queries is something that, you can think about in two different dimensions, right? One is how can you make a detection as granular as possible? So one of the neat things about LMs, you might have heard the term fine tuning, but conceivably, if you feed it a lot of content, right? And you're able to do that in a way that the machine is, or the model is able to sort of extrapolate and generalize about behaviors in your environments, right? It is very possible that then if I were to write a rule, that it could potentially give me much more granular predicates to use in my search query correlation. So that is something that, as a, budding detection engineer myself, right, is something where I get benefit from having someone, co-pilot, as Scott said, right, kind of looking over my shoulder and helping give some hints. Now, the other dimension where I can leverage the, improvement in terms of the queries and searches that I do is in optimization, right? So particularly in Splunk and SPL, that's definitely not my strong suit, even though I did work at Splunk, right? I went from, I improved quite a bit, but I still have some ways to go when it comes to SPL optimizations. But that's something that with LLMs, that code generation really plays well into the wheelhouse of some of these models and really can provide great actionable tips that you can use and employ to make sure that your queries are not only, as granular and focused on the activity you want to detect, but also will run well on whatever platform they're run, that they're being executed on. Now, in terms of another interesting opportunity with LLMs for detection content is it'd be nice to just write content, right? You don't want to have to write it for Splunk. You don't want to have to write it for Snowflake or a traditional database with ANSI SQL, right? So one of the neat things too is with these LLMs, we've noticed the capability for them to write once and then rewrite for whatever data lake that you're. So this is a really neat thing as well, is that you could come to the point where, let's say you created a special language that you wanted to just say, hey, this is the thing that I want to detect on these fields, and then the LLM could make you more efficient and just say, okay, I'll translate what you've described, could be English, could be a domain specific language, into whatever query language on whatever platform that you're running. So yeah, I think like, the term, one of the things here is that for that content improvement, for optimization, for making search queries more granular, as well as make portability, LLMs can be quite useful. So Scott, let's talk about those search capabilities of LLMs
Yeah,
themselves.
and actually, before we do that, I had one thought on the content improvement. I was thinking about something you were looking at yesterday, where a very subtle change in the rule syntax had a pretty big
Mm,
impact on how the rule was being evaluated.
oh yeah.
I don't know if you have an easy way to describe that, but give you a shot.
What was it? Yes, no, it
The
was
with
looking.
the quotes around
Yeah, the quotes were unfortunately in the wrong spot, right? So basically, that would have been a great opportunity for the LM to explain, like, for this particular predicate, right? It's actually searching for it in the string versus looking for a parsed field that had that value, right?
yeah.
And that seemed to potentially cause an issue with the execution of that.
Yeah, and one of the things I was thinking there is it'd be pretty easy for someone to, make that mistake or not think about how this subtle difference in how the rule is written could have a big impact. But LM might be able to explain, this is how this detection is working, and it help them understand if that's the direction they want to take.
Mhm.
Cool. Yeah, with that, we'll go to the leveraging advanced search. So you may have heard of RAG, or retrieval augmented generation, but we'll talk some more about that coming up. But it's definitely something you should be looking at for leveraging LLMs in the SOC. And two ways you might use that. One would be thinking about your institutional knowledge. So imagine you feed into an LLM and RAG all of your deployed rules. Now, a new analyst that joins your company could come ask, say a chatbot, what rules do we have deployed that detect XYZ, or what rules do we have that apply to the MITRE tactic or technique XYZ? And then they could come back and quickly give them, that list of rules, and really help versus, what in the past might be like, hey, go over to somebody who knows, all that, or maybe nobody knows all that, somebody who knows some of that, find the bits and pieces. But yeah, and you could also think about, including previous investigations. Maybe you could include all the notes from your previous investigations in that search and have it say like, oh, we've had a number of investigations around this kind of attack, and they resulted in this result. Another way you might leverage RAG would be threat intel. So you could put in all your threat intel feeds and search them. I could probably rattle off a couple different searches. That'd be pretty interesting. But you can probably use your own imagination there and think of a few. One I'll give you is what are common tactics or techniques for XYZ threat actor that we're concerned about? Or maybe even combining the rules that we have deployed with your threat intel. What rules do we have deployed that cover the tactics and techniques most used by APT for something like that? Pretty interesting ways you might be able to combine a lot of data and then leverage the LLM to reason about it.
And then I'll put, on the last point too, and something that might be useful in your SOC in terms of helping your analysts, right, stay fresh, keep their mind sharp, right, is when we look at all the alerts that are coming into your SOC, right, being able to rank and reorder them might help in terms of like, how do we make those analysts, be most efficient in terms of dispatching or dispositioning those particular events coming through. So for example, I mean, imagine if you had to look at 150 sort of IP alerts in a row, right? Like basically, hey, this is a strange IP that went to that this machine went to, and blah blah blah, right? And that could be very tedious because there's a lot of manual effort right now in terms of being able to get all the supporting evidence. And again, that's where LLMs can help not only automate sort of the collection of any sort of supporting evidence, such as what ASN does this IP belong to, but also say like, let me just take a quick browse of, the Shodan reports or any third-party intel for those particular IOCs. And really, the nice thing about LLMs is they can deal with infinitely tedious tasks, right? I'm not gonna lie, right? If I read about 100, reports from Shodan, I'm not as sharp on the 101st one, right? However, what's nice about these particular technologies is that they can get a sense of what's important to you. You can personalize them to give them examples of things or reports that you find interesting so that only the very best alerts come to the top of your queue. So one thing is, we talk about all these great use cases, but and I went forward one, but
We have
really
a question in chat actually. Can we really quickly before we flip over?
sure.
We have a question in chat of what are some of the limitations of LLMs for SOC use cases that you could call out?
Yeah, I can speak to that. Thanks for the question. Definitely one. So Mike was talking about ranking events. You wouldn't want that to be your only source of, you wouldn't want to say we're not going to have any other system or people or processes reviewing detections. That shouldn't be your only thing, but it could definitely be a supplement or a value add. That's definitely one. I don't know if you got any, Mike.
Oh yeah, I would say like one of the biggest limitations with LLMs, remember, because they are generative, right? And they really, a lot of them that you get off the shelf, right, from be it, Anthropic or OpenAI, they tend to be based on, human, they learn on human feedback, right? And I do notice that sometimes when it comes to fact, that yes, there is a hallucinatory property to some of them. So if you ask, an LLM sort of an open-ended question, I've noticed that a couple times that when we kind of experiment with them summarizing, maybe triaging, you have to be careful that it may invent things as going through. So, for example, it might make a very bold assertion about child and parent process, even though it doesn't have necessarily any context that suggests, with what frequency that those parent and child processes are related. So, yeah, that I think is where you have to just, when you figure out what tasks that you want to apply, having the LLM be as myopic as possible, right? And not allowing it to maybe ruminate on things will then yield probably better results. And a great question from Corey here too about, which particular LLMs work better, right? And I think that, I would just take a stab here and say anything that you can fine tune. So if you take something off the shelf, if you take particularly the latest versions like GPT-4, and you can have the opportunity to fine tune it, or if you're able to, if you take GPT-4, we find that it has pretty good capabilities. They've done a better job of, ramping down or tamping down on the hallucinatory properties. That I think as a first start, if you want to experiment very quickly, then GPT-4 is a good bet, and you can get that from a variety of providers. But I'd say that being able to fine tune, and particularly what my experience has been is like fine tuning models off Hugging Face that, like for example, the Llama 2s. On whatever domain specific task that I have has really yielded very promising results. So Scott, what's your take?
Yeah, no, I think you hit it. I was thinking about how, we've been doing a lot of work with improving the transformers that we're using to feed into various things, not just the LLMs, but we're using that in a lot of respects.
So yeah, so let's go and talking about, here I am saying fine tuning. So one of the questions that you may ask yourself, right, particularly like, hey, this is a new technology and there is a cost of like learning a new technology, being able to adopt it and streamline it, right? One of the questions you may have is like, how much math do you need to really be able to maximize your LLM, right? And I think that what we have found internally is that, you can develop successful detection engineering strategies with these off-the-shelf, LLMs, your GPT-3s and 4s, with very little understanding of the theory. That there's a lot of great resources out there in terms of prompt engineering, explaining, what are best practices, in addition to a lot of great off-the-shelf open source technologies for vector databases that will really help you be able to build out any kind of application. What we also have found out, and I alluded to, is that we do take certain types of LLMs, like the smaller style transformers, like your BERTs, and be able to fine tune them for very specific tasks. So that basically you are able, have that capability to, work with these models programmatically and then train them like you would any other kind of deep learning model. You can do some it creates some very novel models to kind of detect things that you want, but that's not going to be the bar. No, you can definitely be able to use these technologies in very useful ways. And let me show one that does not require, again, really a lot of math, but really just understanding like how best to do some prompt engineering and really having the model focus on, achievable tasks. So here's an example of some detection engineering with GPT-4. Right. And again, with the prompts, I definitely recommend that there's a lot of great resources on how to write these prompts in a very effective ways, how to give it tips on how to think and to produce output. And as you see here, this was the process of multiple iterations, but not too many iterations, to eventually get to a prompt that says, if I take a PowerShell snippet from VirusTotal. So this one was labeled malicious. And if you take a look here, and I love, Jeanette, how we record this so that people can keep me honest later, what we see here is that basically PowerShell is effectively executing, fileless malware by creating a TCP connection to this IP, reads the contents, runs it through IX to execute whatever, and then goes on its merry way. So if I take a look at this, if I wanted to create a detection to say like what is interesting about this particular command line, that its features that I could create a detection to alert on that will help me find other kind of interesting, potentially malicious usages of PowerShell. As you can see here, after some guiding with the prompts, that it was able to kind of pick up on that, using TCP client, right, from the system API is kind of rare, right? I just, from my own personal experience, I haven't seen a lot of people write PowerShell that gets executed on the command line using TCP client and then feeding that into IEX. So again, this is an efficiency play, because at the end of the day, that you're still going to want to look at the results of this particular process. You need to create a pipeline in order to feed it into GPT, but it generally will if you have the right prompts and the right data and the right objectives, it can really minimize the amount of time to create new content for things that you want to detect. And that ultimately, again, you'll still want to review the results, but if it saves you the time of creating, looking at it, digesting it, writing the queries, all that can be done by GPT, and really you can look, fine tune it so that the amount of work that you have to do for a net new detection could be, reduced greatly. So let me also show over here. So Scott, why don't you run through an example here of maybe a little bit more complicated application of LLM?
Yeah. So excuse the acronym soup, but I'll go through them all. So we got UEBA, User Entity Behavior Analytics RAG, Retrieval Augmented Generation, LLM Large Language Model. Say those 10 times fast, but anyway. So I'll take you through an example where we might combine some of these ideas we've been discussing. And the basic idea here is we're going to look at an event and we want the LLM to reason about the event, think about it, maybe make some kind of recommendation or something like that. And to help it do that, to make it have a better chance of coming to an accurate outcome or valuable recommendation. Really, one strategy is to gather a lot of supplemental information. So you might have your event, and then you might have, say, you have a user entity and behavior analytics platform in place, or you have some way of calculating baselines to understand what's normal. You might have, say, we'll say we have a process that we think suspicious, and we have a parent process that also looks suspicious. So we're sending that to the LLM to be evaluated. And then we also include how frequently in our environment we see that combination of process and parent process together. So then now the LLM has some, idea of what's normal for our environment. And can use that to help reason. Another thing I'll say on this, just because I think it's pretty relevant, pretty interesting. I've spent a lot of time looking at how to RAG, and one common stumbling block I've come across is many of the frameworks that help you implement RAG with an LLM don't handle structured data well. And what I'm saying there, or an example of that, would be, imagine you have on this event, you have a couple fields that have, like, bytes in, bytes out, and then two numbers. But then say you're trying to feed, a lot of historical information about bytes in and byte out, columns like that on events, past events, to the LLM. One thing that I've noticed happening is, so imagine a CSV, right? And you have column bytes in, column bytes out, and then a lot of numbers below that. The LLM may just see the numbers and not the column headers. They might get lost. So you're losing the structure of the data, and then those numbers are pretty meaningless to the LLM. So definitely something I'd watch out for when implementing RAG.
Exactly. We got a great question here about, scenarios where you find fine tuning is more valuable than RAG, right? So I think, like, there are definitely tasks. Let me throw this out there for the fine tuning. I think right now, one of the things I'm really excited about and I'm experimenting with is in natural language processing tasks. There's a goal of, like, text to, basically translation. That basically, maybe I take an original piece of text, maybe it's English, I want to translate it to Spanish. So in a situation like that, that we can still use LLMs. RAG wouldn't be the appropriate tool, but what's nice about that, particularly from a security detection standpoint, is there is an opportunity to take things where if I have maybe some, like, for tuning recommendations, right? That basically I have some content, I have a query, I have a detection, I may have an abundance of false positives. What's in a way that I can, ramp down the number of false positives by perhaps creating an allow list expression that allows me to say, if this regex matches log, you can ignore it for the purposes of, in that situation with a text to text or sequence to sequence model, right? Then that is a great fine tuning task. And particularly if you couple something like, like a llama sized model with, QLoRa or some way to basically efficiently relearn or remap weights, right? So that would be a good sample of, where a fine tuning could work. I think we're also just actively as a company kind of thinking about, what situations does RAG make more sense than trying to teach an LLM straight up. Because what we found too is that there's some debate on this online, and these are some of the, really the open questions, right? In terms of, is it better to have RAG, or is it better to, find source materials and teach the model so that you're not, that you can just query it straight up with a prompt without having to add RAG context. But Scott, what would be your take?
Yeah, I definitely agree with what you're saying there. I think it's definitely an open question. From my perspective, I think I can speak more to RAG and just saying, there's some big advantages if you have pretty well structured data, or even unstructured data, but taking it back to your threat intelligence, or the threat intelligence example, if you want to query that, you could search. Many of the queries might be related to a specific group, or other keywords that can be set as metadata attributes on the documents that you're going to RAG over, and I think you can get some pretty good results out of that. But yeah.
So I think basically, it is, mileage is going to vary. And I think that it's important for experimentation and the best that you can, if you can make it as easy as possible. For example, if you have a vector database that you can kind of spin up and use that's large enough and capable enough, right, for you to, experiment with RAG. Fine tuning is a bit tricky, but there's great tutorials online from places like Hugging Face, and Axolotl is a open source tool that I've seen. I haven't had the pleasure of using it yet, but also makes it fairly efficient to run or train or fine tune, excuse me, the LLMs from the switching gears here. So we're talking about LLMs, and right, lots of great things you can potentially do with them. But the question is this a theoretical exercise? We're saying, hey, these are great use cases, but like no one's really going to do it. But what we want to share too is like sort of like how we couple our LLMs with our security data lake, right? And what we found is that, with different security data lakes coming online, for example, we use Snowflake, right? We've been able to effectively use LLMs over our security telemetry, with different types of inference strategies. So what do I mean by inference strategies? I mean that how do I want to execute this LLM? So one of the things that we've been doing for over a year now is we have smaller type LLMs, so these sort of BERT style transformers that we've fine-tuned, and that basically we've created user-defined functions in our so like warehouses. We're able to do things like, does this look like a malicious URL? Does this look like a misparsed command line? And that we're able to co-locate that compute with our storage, and then it makes it very easy for us to get results and hopefully, using these more sophisticated models, right, get better, to effectively get more accurate, more insightful results from those processes. Now,
Yeah,
yep.
let me jump in there because I want to say something. Actually, you said that in the past, but an example of what Mike was talking about there is, you can imagine driving a sports car to the grocery store or, a sedan. Both will get you to the grocery store, and there may be reasons you want to drive a sports car to the grocery store, or maybe a sedan works just fine, and for this case, it's more practical. So yeah, that's another way to look at it.
Exactly, right. And for those UDFs, for those really kind of specific tasks, right, then the size language model you can, that you really need is actually much. It's that Toyota Corolla is probably the more cost efficient way, right, to get to the grocery store than the, Bugatti. But however, if you want to go to the racetrack, right, as much as I love my Toyota Corolla, still running, still in the family, right, you're not going to race that in NASCAR, right? And if you do need these larger models, what we found is that, with Snowflake and other security data lakes, right, it is possible to connect to your third-party, model providers, right, be it OpenAI or Hugging Face or what. So I think that you get a lot that basically whatever use cases that you can imagine, the kind of cool things that you do, I don't think they're theoretical at this point, right? Given the sort of maturity in the security data lake space, right? What we found with our, with our Snowflake databases or warehouses, right, that we've been able to leverage these technologies in many different ways to achieve, more insightful outcomes using this particular. And just unfortunately, SIMs or legacy SIMs, don't have that sort of accessibility of the data and compute to be able to do those kind of inference. I think the other key point too is that when it comes to security data lake, the more that you can keep in your hot tier, that it is accessible, that it doesn't have to be decompressed from a cold data storage, like things like Snowflake, for example, right? That allows you to sort of consolidate all of your training in one spot and be able to provide that to your LLM, because particularly for fine-tuning exercises, right, you will benefit by having more data accessible for that training operation, and particularly where it's accessible in a language that like be it SQL or what have you, it makes it easy to slice and dice it for your needs to train your particular LLM. So let's go and shift gears to the final topic here and talk about, how LLM safety, right? So we talk these things are remarkably capable, but are they safe to use? So I can just speak to accidental adversarial attacks on machine learning. So I have a, electric vehicle every time I park in my garage, which is exceedingly messy. About, every week I am told that there is an 18-wheeler in my garage that I'm about to collapse, right? Because unfortunately, my garage is quite messy. It messes up all the, computer vision models on my EV, and it just imagines and hallucinates all sorts of things that are in my garage that quite frankly are not there. Because definitely there's no 18-wheelers in my garage. But I'd say, like, Scott, what have we learned? What is the latest here on adversarial attacks for these machine learning systems?
Yeah, I think we actually have a lot to say on this one, but I liked your example there. Yeah, so one example here on the screen is from NIST, and they're just showing where, the AI might be tricked into seeing those deceptive road markings in red there and then directed into the wrong lane of traffic. Another common example that I've heard that I really like is, and I think there's been a number of papers on this or on things like this, but imagine the vision model is looking at a sign. It's a stop sign, and most of the time it thinks it's a stop sign, but now someone comes along and is able to poison the training data or otherwise impact the model. I think there might have been one where they were putting special tape over the stop sign, and that tricked it into thinking it was a speed limit sign. So then now instead of stopping, it speeds up through the intersection. Those would be pretty severe ones, and ones you wouldn't want to have happen. But we'll get into why that may not always be as big of a problem for many cases as you might think. So yeah, we'll look at some of the challenges and safeguards. Some of the challenges, there's a number of different vulnerabilities that have been released. We have prompt injection, which is hijacking the models by using a clever prompt. So just some interesting prompt that gets an unexpected result or something that's unintended. Prompt leaking is another term I ran across, a little less commonly used, but it's a form of prompt injection where you get the prompt to, or the LLM to reveal information that it's not supposed to reveal. So an example of that is, people have been able to extract some of ChatGPT's training data using prompt leak. But you can imagine, maybe it's some kind of PII that the LLM has access to via RAG, and someone's able to get it to maybe send the wrong person's PII to them. Another one that's pretty interesting is code execution. There's some really cool capabilities in AutoGen, which is a framework out there from Microsoft, and it can do some really neat stuff. Like you could write a prompt saying, someone at our company has actually done this. Write a prompt saying, go to this website, download it, analyze it, et cetera, and then it wrote Python code and executed the code to actually download the website and then came back with some interesting analysis. So you can imagine how that could be used in ways that are not good. You want to take data poisoning, Mike?
Oh, data poisoning, this is an interesting one that I was reading some papers last night in preparation for this particular, conversation. And I think that it is possible, and there's some, great work out of Google and Zurich about, it is, for these different training sets, like things that people put on Wikipedia, basically sourcing from the internet, from Wikipedia, from popular domains, that being able to purchase expired domains so that inadvertently you can kind of sneak things into the training sets for these larger commercial models. As well as with Wikipedia, yes, if you write something bogus on Wikipedia, very common that it will get reverted very quickly. But you can actually predict when snapshots will be taken, and those snapshots are used by different, LLM providers in order to train. So basically, you can put your malicious or poison data into these snapshots by just knowing that, hey, in about 10 minutes, Wikipedia is going to snapshot or take this particular page. I'll put my information in there. It will get reverted, but it will persist indefinitely in the snapshot that one of these commercial providers will be training. So yeah, I think like it's hard to say exactly how that can affect your models, but definitely if I were a nation state adversary, right, it may be very interesting to see how I can, blunt the ability of these commercial, LLMs, right, to help work in cybersecurity capabilities by putting out misinformation that may lead the model to not give you good results or good interpretations of their particular attacks, right? But again, it'd be very hard to really make that concrete. So yeah, so Scott, hallucination.
Yeah, so intentionally or accidentally. That's what I got for you. But no, so you can imagine, again, back to prompt injection, getting the model to say something that it wasn't intended to say or wasn't expected. And a really great example of that, so this Wired article, or mentioned in this Wired article, where Canada Airlines, someone was chatting with their LLM and it made up or hallucinated a refund policy that didn't exist. Then they took Canada Airlines to court, and the judge ruled that they had to uphold the refund policy that the LLM made up. So that's pretty interesting one of hallucination. And I think that's a pretty good example that gives you an idea what it is and why you might want to be concerned with.
But
Oh, go ahead.
I was gonna say, yeah. So I was gonna say some safeguards we can use, right, to help kind of harden your LLMs to make sure that what whatever output, and particularly output that goes to customers. So Scott, this is an interesting one. Supply chain risk process.
Yeah. So one of the things I really wanted to emphasize on this was, there's a lot of new vulnerabilities out there, but a lot of this isn't really all that new. Like there's, you're getting you're getting a model from somewhere. If you're worried about the model being poisoned or impacted, upstream, then that's a supply chain risk, and you can deal with that through existing supply chain risk management processes that you might have. And in those processes, you'll probably look at the probability and the impact of risks like this happening. And, I think in many cases, the end result will be it may not be your highest priority if you really look at things. There's probably some more higher impact and higher vulnerability things you might need to worry about than adversarial attacks on your LLMs or ML. But I will add that, it might not always be the case. Example would be the self-driving car, where I think it'd be pretty important.
And let me speak to this design with using least privilege. So I've done a lot in my career with data loss prevention, and definitely, and we talked a little bit earlier about when should we fine tune versus RAG. So one of the challenges definitely with the fine tuning, if that's not coupled with, so a certain prompt safeties, right? Reviewing before executing LLM, looking at the prompt to see like what it's saying and, what its intentionality before then passing it to a purely generative process, right? That with basically RAG, with fine tuning, if we are very deliberate about what data is actually made accessible and then what the LM will consider as it's creating its responses, then it is very possible that you'll make sure that you have the sort of whatever response that you have, whatever information share, won't have inadvertent leakage. Now, it's not impossible, right? And it will be very important that as different groups test out these different mechanisms, that there is a third party looking at it in a statistically sound way to say like how often does it hallucinate, how often does it go beyond go beyond its sort of instructions of what it should be providing. But those kind of frameworks, those sort of statistical approaches, are things that are being adopted in the actual generative AI industry, and that there are tools so that you don't have to come up with the procedures yourselves, but there'll be available tooling such that you can, make sure that you're systematically verifying that not only are you providing, the least amount of information to get an acceptable response, right? But also that you're checking the outputs and you've checked enough outputs to be ensured that it will reliably stay within the bounds of acceptable outputs. So again, those are definitely challenges. And I think for Scott, for me, and I think for us, like what we try to do is really try to keep the LM as myopic as possible and try not to have it generate too much text. But absolutely, I think that one has to be careful about what data is provided. And particularly if you have in your company, a group that has access to sensitive information, that they have to be really mindful about what they're training on and what safeguards are placed, particularly what's available. Excellent. And then I was going to say, parting thought on this, Scott, best practice.
Yeah, so definitely some best practices out there. MITRE is Atlas. I guess that's a framework. I'm not sure, but it has tactics, techniques that people are using. An example would be prompt injection that you can take a look at and get an understanding of what the vulnerabilities are and things like that. And NIST has also recently put out some information around it that's also useful. One of the things I'd add too on the designing using least privilege would be, one example of using the RAG is you might give it access to query a database, and that could be powerful. It could learn a lot or answer a lot of questions, but maybe you don't want to give it access to write or delete, or maybe very limited access to write or delete to the same database. And then just like Mike was saying, sensitive information definitely would probably be a best practice to limit that or be very thoughtful when doing that. Yeah, one other thing we got is actually came out from our threat intel team at the Forge today was, and we thought it was pretty interesting and worth sharing, but there is a model that was found on Hugging Face, which is a popular model sharing website, and the model was named Baller 423 Goober 2, and you're shaking your head, Mike.
Oh my goodness.
Yeah. Anyway, yeah, so it's a PyTorch model, but it included a reverse shell payload in the pickle file that was being used to contain the model. So definitely interesting novel attack that's out there. But if you think about it, it's similar in many ways to other supply chain attacks. There's been numerous Python packages that have been released that were malicious or tampered with. So it's another extension of that.
Oh, a great point. Yes, I mean, definitely in your sec DevOps, right? You have to be very mindful about, okay, where are we sourcing these things? And really, like, yeah, LLMs, the ones that you're going to fine tune. I mean, they're a dependency like any kind of Python package, Java, Node, any other kind of programming language, right? So, but it would be very important because if you have people in your company that are using these particular models, right? It might be really hard to track who's doing it and getting integrity checks on those particular models. So this is definitely a challenge, and it's a good opportunity to help people pump the brakes on basically what are their development practices, and making sure that Kubrick 42 doesn't accidentally slip into some sort of build. Cool. So I think that is that for what we have for content. So question.
So a lot of people have skepticism about using LLMs for SOC use cases because of the sensitivity of the data. Scott, when you were talking about RAG as an example, right? You're like, oh, maybe I'll put all my detection rules, or I'll put all these things in there as kind of a way to reference that. How would you do that safely? Because it seems like there's a lot of concerns about the data leakage and a lot of things that people could get access to. How do you ensure that you're not exposing yourself or putting sensitive information out there?
Yeah, I think it's a really good question. And, one of the things would be who has access to use it. So if it's your internal security team and they're the only ones that, I mean, that would be my recommendation for that one would be, only your internal security team should be able to use that RAG that's operating on all your rules.
So it's about setting up those proper enclaves and, not using ChatGPT, right?
Yeah, and access control. Yeah, definitely. But I think that's a really good point. And that's where, maybe even you do have some use cases where, let's see, there's a question about PII, but yeah, maybe you do have some use cases that have PII in them, and maybe it makes sense to have an LLM out there, but just very limited who could access it. And maybe they're people that already had access to the information. It just lets them access it more easily. Or yeah.
And Tim, this is a great point. Also going to Corey's question as well. I think you absolutely have to monitor the usage and why are people, accessing these. So let's say I do have a case, right? I'm trying to do some incident response, and I want to, there is probably the questions I'm going to ask should be pertinent to the work that I'm actually looking. So there's opportunities not only to say, does this query make sense in terms of what this person is doing right now? Because I know that this person has these tickets, they should be, looking at remediating these machines, either the issues, right? But if it's asking oddball questions, right, that would definitely be an issue, right? And then I think the other thing is you always have sort of like, the issue of the insight, right? And particularly with that access to PII, it is very important to kind of baseline, what is expected usage, right? And expected usage is not only just like what content they're asking, right? But how often are they asking that, right? When are they asking that, right? And does it comport with how the usage of their call? So ideally, if you can kind of baseline individuals in the organization, and particularly those who have access to PII, right, that there should be some consistency, right, in how they're operating, so that someone who is in a different department really shouldn't be exhibiting the same behaviors and using these systems, than someone in a different. So almost like if we think about traditional database model, what queries are they using, what databases that they're hitting, right? I think we have some good senses on UEBA type strategies to really make sure that they are using that particular information. One last thought here too is, you can implement something like a credit base that basically, if you notice that someone is using these systems exorbitantly, then it's time to kind of ramp down their particular usage and try to understand what are they doing and why are they doing. So really just thinking about like how anomalous this particular access is by virtue of what question it is, what documents were retrieved. It has a lot of analogs to sort of the database monitoring.
And I will add on that there's a number of tools that are coming out on traceability and monitoring that give you pretty insightful information that, like Mike was saying, we capture all those things, capture the queries they're running, how frequently, maybe what documents were pulled back.
These are great questions, Tim. I'm having flashbacks to my data governance days when I worked for this product called Data, right? And it's just it's really, you do have an opportunity if you structure, you do the traceability, you know what the queries are, you have the sources, then you can start piecing together, how unusual, right, is this line of questioning, these accesses, given their baseline behavior.
Yeah, I mean, I totally get that, right? Where you're trying to keep track of are people using the LLM responsibly or using it to gain access to unauthorized information. But I guess my thought was even more basic than that, right? Like by creating some of these things or leveraging what to Corey's point, an external LLM, right? Because I think that's the danger is people are so excited to jump in and use these things that it's like, oh, I can just go to, chat GPT on the internet. And there's a lot of danger there of trying to leverage those public ones. So just being able to use that responsibly, I think is an important point, right?
Absolutely.
I think that also ties into the issue where you see a lot worse performance using the local models, especially like the 7 and 13 billion parameter models for something like RAG. They just tend to not be that great at following the instructions of looking through the context and whatnot. And that really increases the likelihood that people will use external models and end up pushing their data straight to them through RAG.
Yeah, it's the old adage, we got to make it easy for people to do their job the right way, otherwise they do it the wrong way, right?
Good point. One thing I would say is there's some options from Azure around deploying, OpenAI models in your own cloud environment. So that might be a little bit of a middle ground, maybe. But I guess it depends on your take.
Hey, yeah, I'm looking for that UEBA based use cases that you have highlighted before. So if there are any attacks that has happened, or if there are any data poisoning that happened in between the model learning period or during the production phase, how are we going to relearn or roll back? Those kind of question is my question basically.
Yeah, I
Pertaining
think
to
that's
UEBA.
I think
Yeah.
that's a pretty tough question, but I imagine you could have some snapshots of the models as you go along, and if you realize at some point that it's been tampered with, you could revert to before that. But I don't know if you got anything, Mike.
Well, this is a great challenge, and particularly in a fine-tuning scenario that all of a sudden even with those particular checkpoints, right? It may be hard to trace. Like, let's say there was some data poisoning, you detected it, but you don't know how widespread it was. So I think then you may have to think about as you design these applications, right? Absolutely, we're going back to this idea of supply chain, right? And really trying to safeguard as much as possible what you're sourcing, and then also maybe changing the model so that, and this may be an argument for RAG, where if you have to unlearn, maybe then you do kind of push it to an in-context learning solution, where with the RAG that you can eliminate the things that you suspect are have been poisoned or have been altered, right? And yeah, I think then at that point, the question would be too is when it comes to the prompts and understanding and versioning the prompts, that will be also very important to keep track of as these systems are used, more users are using them in sort of novel ways and creating their own applications on top of maybe vector databases that a company provides, right? Then having safeguards to sort of say, okay, when did checkpoint and understand when did these prompts change, how did they change, and if that change is significantly different from the original, so maybe somehow an adversary was able to slip something in, right? Then that will get a review. So these are excellent questions, and they haven't been fully solved, but it definitely behooves that, when you do these particular solutions, the best that you can to make things as explainable and as tractable as possible, and not allow, put yourself in a position where it's hard to keep track of, who's saying what in terms of, allowing the model too much flexibility in terms of what to output in addition to what you're ingesting to train said model. I think those are the challenges, is getting those balances so that you have some guarantee or modicum of safety.
And that kind of ties back into what you were saying earlier about, how widely you scope the model. So maybe you have an agent with multiple tools at its disposal, and it's, it can ask 20 questions to 20 different databases, just an example. That's pretty complex. There's a lot more chance to go off the rails than a very simple RAG with a single index, or maybe even just a basic prompt. So something to think about how you design and scope and the trade-offs of that.
Awesome. Well, we are at the top of the hour. We love the discussion, love the questions. I think this has been an awesome hour with Mike and Scott. So I appreciate We appreciate everyone that joined today. Something that Scott mentioned, the threat reports that we release weekly, you can actually subscribe to them. Our Forge team releases them every single week. And we also have a GitHub repo that we launched last week. The team launched, and it has a lot of awesome content in there that you can leverage. Feel free to check them out. But otherwise, stay tuned for our next episode in 2 weeks. And if you have like feedback or you have certain topics that are super interesting to you and your teams, you can provide that feedback to me. You can chat me. I can follow up with you. And if you have interesting topics, we can pull together a session for you. So thanks everybody for joining. We will see you in a short 2 weeks. Thanks everybody. Bye.